Welcome to the ICS4ICS Incident Command System for Industrial Control Systems Cybersecurity session. My name is Wally Magda and I'll be your presenter for this session. An independent contractor, I have a veteran-owned business. You can read all the other details here. I think what's important is, like many of you, we all graduated from SOHK, the School of Hard Knocks Life, what we see out there in the field and what we're learning. In this presentation, we're going to take a look at cybersecurity objectives and standards, threats and vulnerabilities, what's out there, the layered approach to protection, cyber defense methodology, computer incident response. This is meant to be a high-level review of cybersecurity. Cybersecurity objectives and standards. What are they there for? We want to protect data systems and components from loss of availability and integrity and confidentiality. We have AIC. Those are the three basic tenets of security, cybersecurity. Want to define the organization, the staff, processes required to ensure that capabilities are going to be effective. Define how to secure data, systems, and technology components. Want to achieve a high common level of security. There's various approaches to this. The definitions and the standards and frameworks, such as NIST special publications, ISO 27000 series, ISA IEC 62443, are just a small sample and not meant to be prescriptive. Applicability depends on your internal, local government, national best practices, safety, recognized and generally accepted good engineering practices, RAGAGEP, and process safety management. The directives, such as the European Union mapping of operators of essential services, safety requirements, specific sectors, number of different standards and frameworks that are out there. They may not be mandatory. They can be used to create your information security management system, ISMS, or shore up what you already have in existence. There are certification programs for products. It allows the providers to demonstrate that their solutions are secure. Typical cybersecurity org chart that you find in most organizations, its focus is on cybersecurity. These are the types of roles that exist in medium and large companies. Now, the Chief Information Security Officer at the very top. Up here, the security architect. You may have a team of network folks, server infrastructure, policies and standards. Then the Computer Incident Response Team, CIRT, C-I-R-T. We'll use that acronym a few times. There's a Security Operations Center and a number of analysts supporting these functions. What are we trying to protect? How are we going about this? Adversary is threat sources, has intent, capability, and the means to do it, the opportunity. They perform reconnaissance to identify potential targets in a network, whether it is IT or OT, information technology or operations technology, or physical security. They launch the attack threat event, taking advantage of exploits on existing vulnerabilities. There'll be some type of a consequence that's going to happen, like encrypting files. What do they cause? They encrypt files. Use ransomware, trip safety systems maybe. That makes an impact on business processes and production. Some of the threat actors out there are the typical criminals that we hear about every day. They seek financial gain, ransomware being one of them. The hacktivists, they seek to negatively impact reputation, drive attention to a cause, pressure for change. Nation states seek economic, political, and military advantage. Then the insiders, inadvertent human error. Click on the wrong thing. May seek personal advantages, monetary gain, professional revenge. Humans will always make occasional mistakes. Click on a phishing email link that compromises your systems and data. In any case, you need to have some type of a plan for recovery. What is your plan for recovery? We all have cybersecurity vulnerabilities in our systems. These vulnerabilities quickly evolve. They're very challenging to protect because they keep changing. The bad actors attack networks to identify weaknesses and vulnerabilities. The software you have, do you have a software bill of materials? How do you know the software you're running is malware free? Supply chain vulnerabilities are difficult to identify. You have trusted software suppliers and you have a bug in the software impacting many companies. Is it a bug or is it malware? Social engineering is when bad actors engage staff, trick the staff to take actions that compromise confidentiality, integrity, and availability, our basic tenets of security. So what can we do to minimize these risks? This is all a matter of risk management. We can take a look at our threats and vulnerabilities from a perspective of the security triad: confidentiality, integrity, and availability here on the left. What is our adversaries triad? They want to disclosure, they want to corrupt the data, corruption, or just total destruction, denial of service. Which one is the most important to the industrial control system organization, and which one is most important to the adversary? How do we protect against this? We could use a layered approach to protection. There is no single cyber defense measure. There's no silver bullet that can absolutely protect from a cyber attack. We want to look at our different layers, and these are not prescriptive layers. They're just put here for discussion. The perfect circles in the real world, it won't be a perfect circle. You may have more emphasis in one area than the other, depending on your business. But we have to have some type of provision. We have to have the physical security, the policies and procedures, malware prevention, access controls, monitoring, detection, patching. User training is required by the policies and procedures. In layers, the intent is to delay, if not prevent, an attack. Defense in depth implies the layers of security and detection, even on a single system. Yeah. Attackers have to break through or bypass each layer, hoping not to be detected. A flaw in one layer can mitigate capabilities in other layers. System security becomes a set of layers within the overall networks. It's not perfect, may require more emphasis in certain layers, and that's where we need the computer incident response team, the CERT, to manage events which unfortunately will occur. So securing your system using another triad here is the people, process, technologies. These are the basic principles for ICS cyber defense. So how does that organization leverage its people, process, and technology to protect itself against the cybersecurity threats and vulnerabilities? People require specialized and continuous awareness training. Process requires that policy and procedures are kept current and enforced. Technology refresh, upgrades, retrofits. Are you still running that control system on a Windows NT platform or a Windows XP? Maybe so. We want to be measurable for each action we can do. We can't achieve operating safety without cybersecurity, and you can't achieve cybersecurity without physical security. There's three key stakeholders. It's a continuous process. We have the asset owner. They operate, maintain, do the routine maintenance according to their security policies and procedures, with a shared responsibility from the system integrators that commission, validate controls, safety, and complementary functions. They help put out the automation solution and design and deploy. Then the product suppliers, they develop and support components and systems. The cyber defense methodology that we're going to use, it has to have a fine balance. There's no 100% security, whether it's cyber or physical. Organizations can't afford to protect everything, and it's balanced against the cost versus what it takes to mitigate the risks. Got to find that sweet spot here in the center. Along with the methodology, generally we have a business continuity plan, a BCP. We want to sustain business operations. We want to be prepared and have these alternative operations in place. The incident response, minimize the damage cost. It's going to involve pre-assigned and trained teams. You did your preparation. Obtain assistance as planned. Disaster recovery plans, act quickly, efficiently, and safely restore the plant to operations. Despite all your efforts, you get breached. How do you respond to that event? Who are your security operations experts and employees? When is that event classified as an incident and how? Who makes that final decision? There, you need to have that business continuity plan to be triggered to get the functions back to an acceptable level with the resources that are readily present. So in a nutshell, business continuity keeps the organization running during the life cycle of an incident. Incident response allows an organization to handle an incident from the start. Disaster recovery processes brings back some level of normalcy. Being that there is no single cyber defense measure, there's no silver bullet, what can we do here? We have to have some type of computer incident response capabilities, and they're critical to managing cybersecurity incidents. This is where that CERT, Computer Incident Response Team, comes into to help manage this. The OT, Operations Technology Industrial Control System staff, are most likely to identify an event that occurs in their environment. The CERT may have limited knowledge and visibility into the Operations Technology Control System environment, which will delay actions if an event has occurred. The engineers, operators, safety staff may identify events. Physical security staff may identify a breach that could impact cyber assets. One of the ways to do a computer incident response phase is taken from the NIST, National Institute Standards and Technology, special publication 861R2. This is just one approach. There are many, but the basic functions have to exist. You have to prepare, build a plan, training staff through exercises, detect the events by the attack vectors, signs, and indicators, analyze it. Here's the forensics, prioritize, perform escalation. At any time, forensics may be engaged during these phases. You got to contain it to prevent more damage. How are you going to do that? Hopefully you've prepared and have a plan in place. Disconnecting from the network may not be the safest thing to do or the most prudent thing to do. Eradicate, eliminate that source of event, so when you start your recovery, you aren't reinfected. Then post-incident, got to take the time to identify lessons learned and retain the evidence. This publication, NIST SP 800-61R2, Computer Security Incident Handling Guide, is publicly available on the NIST site. There is no additional charge. It's been paid for and developed through taxpayer dollars and grants and such inputs from the community. So we've talked about no such thing as a perfect security. The adversary is always a step ahead of us. We got to plug all those holes. The adversary only needs to find one. We mentioned cybersecurity objectives and standards, what our protections are, our CIA Triad, confidentiality, integrity, and availability, threats and vulnerabilities, insider, inadvertent human error, criminal, nation state, and then what's built into the products, that's a problem. Layered approach to protection. We want to have a defense in depth. Can't catch them at one layer, maybe catch them at another layer. That cyber defense methodology that ties directly into how we're going to do our computer incident response. How are we going to stay in business? The incident command system for industrial control systems can help your efforts here. There's no single cyber defense measure that can absolutely protect you from a cyber attack. You must be prepared for incident response. Thank you for your time. This concludes this presentation.